let's come back and see the trick 7, that is stability of free radicals. So till now we have seen stability of carbanion, we have seen stability of carbocation. Now we're going to see the stability of free radical. So how does the order follow? Remember, so whenever I take free radicals, methyl free radical is less stable than ethyl free radical, less stable than propyl free radical, less stable than secondary, and then comes the tertiary free radical. Let us see what is the reason. So always remember, whenever we speak about primary free radical, right? So methyl, this is primary. Now primary free radical, why? Because there are 2 hydrogens in one methyl group. Okay. So in primary free radical, how many alkyl groups are there? There is only 1 alkyl group, correct? Now in secondary, there are, or if I have to say primary free radical, okay, so 1 alkyl group present in this. So when I take the secondary alkyl group, it has how many free radical, how many alkyl groups? 2 attached to this. Now when I take the stability of the tertiary, there are 3 alkyl groups. So you have to remember, first important thing, the stability of the carbon radical, it increases with increase in number of alkyl groups. Remember, once again, stability, this is important, you have to remember, stability of carbon radicals, on what it depends upon? Depends on number of alkyl groups. So here number of alkyl groups are more in which one? In tertiary, right? Now you have to remember, as the number of alkyl group increases, carbon radical, what will happen? It is stabilized more and more. Due to what? Which effect is here? This is plus I effect. So when plus I effect is there, what will happen? Number of hyperconjugated structures and also increases. The students, yes. So that is the reason. Once again, among all these stability of free radicals, most important, tertiary free radical is more stable than methyl. What is the reason? 2 things. First, more of electron releasing groups. So stability of carbon radical depends on number of alkyl. If the alkyl groups are more, stability is also more. Remember. So in free radical case, here there's plus I effect which is shown, as well as hyperconjugated structures. Number of hyperconjugated structures also are more. Yes, students, that's why the order here, what should I remember? Stability of free radicals order which I have to remember, concept is number of alkyl groups should be more. So tertiary is more stable than secondary, more stable than primary, which is more stable than methyl free radical. This is the concept. Reason is, here in tertiary you have plus I effect more. When the plus I effect is more, that means more of electron releasing groups. Even the number of hyperconjugating structures also more. This is your free radical. So I have shown you the stability of carbocation, stability of carbanion, stability of which one? Free radicals also. Now let me come back and show you the next important trick, that is trick number 8. Very interesting. How to solve acidity and basicity questions. Right, welcome back, students. Let's come back and solve the trick 8. Right, so here till now we have done the stability of carbocation, carbanion, free radicals. I've taught you what is SNLT is. Then I've different types of questions. Now let us come back and do most important, that is how to solve the acidity and basicity type of questions. Maximum I've seen most of the JEE papers, NEET papers, have asked us. Now when an acidity based question is given to you, you have to remember 5 important criteria for that. Let's see. So what are the tricks to remember in acidity questions, whether it is more acidic, less acidic, or what? Right. So here acidity based questions, what is the trick you have to remember? Keep noting it, students. Always remember the first. What are the 5 things? Right. The first thing which you should remember is acidity is directly proportional to electronegativity. First concept. Right? If I have to see the order, for example, electronegativity means tendency to attract the shared pair of electrons. Yes, right. So when I have to see the order, just see CH4 is less acidic than NH3, less acidic than water, less acidic than HF. Now see here, I can directly show you the example here. Just see. Here I said acidity is directly related to electronegativity among all these. Now hydrogen is 1, sorry, carbon is 1, nitrogen is 1, then oxygen is 1, then fluorine is 1. Yes, students? Yes, among all these, which is a highly electronegative atom? Fluorine is a highly electronegative atom, isn't it? That's why higher the electronegativity, stronger is the acidity. Means higher is the acidity. That means among all these, HF is more acidic than CH4. Why? Because electronegativity is more in fluorine compared to oxygen. First trick. Next important thing. Next important trick which you should remember is acidity is directly proportional to anionic size. Okay, students? Next thing, keep noting it. I said first acidity is directly proportional to electronegativity. Next concept is, let me erase this. Acidity is directly proportional to anionic size. Anionic size. Let me take the order. HF is less acidic than HCl, less acidic than HBr, less acidic than HI. Now see the concept, students. Among all these, fluorine, chlorine, bromine and iodine, which size is larger? Which atomic size? This is smaller in atomic size, and this is larger in atomic size, right? Now as we go from top to bottom, number of shells increases and the size of the atom also increases, right? Now I said acidity is directly related to anionic size. So among these two, which is a bigger size? Anionic size is which one? I minus is larger in atomic radii than F minus. So which will be more acidic? HI will be more acidic. So since I minus is greater in atomic radii than fluorine, HI is a stronger acid than HF. Remember this second concept. So first concept is acidity directly proportional to electronegativity, acidity directly proportional to anionic size. Next trick we'll see, students, right? There is a third one in acidity. What is the third one? Order of acidic character. What is the order? Right? Sp greater than Sp2 greater than Sp3. What is this? Basically, this applies to an atom that is losing hydrogen. If I have to take the example, right? So, CH3, less in terms of the double bond, CH2, double bond, CH2, less than the triple bond. Remember this, students. So, order of acidity is the third concept which you have to remember. Single bond, less acidic than double bond, less acidic than triple bond. Yes, this is nothing but the property of losing H plus ions, isn't it? Right. Let us see the next fourth trick in trick 8. That is means the fourth concept which you have to remember in acidity questions. Always remember, whenever electron releasing groups or electron donating groups are present, if the electron releasing groups are more, acidity will be less. Yes. So, electron releasing groups are more, acidity will be less. Electron withdrawing groups are more, acidity will be more. Yes, students, remember this. Yeah. Right. So what you should remember, whenever the electron releasing groups or electron donating groups, the acidity decreases, means what will happen to the basicity? Basicity, it's opposite, nothing but basicity increases. This is what you have to remember as the fifth trick. Done? Now, fifth one. Acidity is directly proportional to resonance. Directly proportional to resonance by stabilizing of A minus. That means, so here what you should remember when I take both, like let us take one example. There is one alcoholic group here. There is one acidic carboxylic group here. Where resonance is observed? Resonance is observed in this case. So alcohols, when I have to say, they are less acidic than acids. Done, students? So acidity is directly related to resonance. Here resonance is observed. So hence it is more acidic than alcohols. So alcohols are less acidic. Right, students? I think I have told you all the 5 tricks. What you should remember, I'm summarizing it in trick 8. Acidity is directly proportional to electronegativity. It's directly proportional to anionic size. If the electron releasing groups are there, the acidity, it decreases. If electron withdrawing groups are there, acidity increases. Last but not the least, acidity is directly proportional to resonance. Right, students? Now let's come back and do the basicity based questions. Suppose in the exam they are asking you basicity questions. Very important. So basicity questions, there are different tricks again, which I'll be telling you in trick 9. Welcome to next trick, that is trick 9. Here in this trick, what type of questions can you solve? Right? How to solve questions based on basicity. If they ask you which is more basic, which is less acidic, or if they ask you which is less basic, which is more acidic. So acidic, already I have given you a clue in the last trick, that is trick number 8. Now we'll see how to solve questions based on basicity. So here basically I'll be teaching you which is directly related, which is inversely related. Right? So here, most important thing, let us categorize the whole concept into different tricks. The first trick about basicity, that is, basicity always increases. When does it increase? It increases with increase in negative charge. That is the first concept which you have to remember. When the negative charge increases, the basicity increases. For example, if I have to take NH3, NH2, sorry, NH 1, 2, 3, 4, 5, 6, and negative charge is 2 minus. Next, NH2, 1, 2, 3, 4, negative charge is 1 minus. Now, if I have to see, according to this, I said basicity increases with increase in negative charge. In which one negative charge is more? First comes the negative charge is maximum in this. First, next negative charge is this, more. Now least is this. So what is the order? If I have to take, yes students, the order would be which is more basic. If I have to see, I have to see whichever has more negative charge. So in this first case, NH 1, 2, 3, 4, 5, 6, 2 minus is greater, it means is more basic than NH2, which has 1 negative charge, which is more basic than NH3, which doesn't have negative charge. So this is more basic or most basic. This is least basic in nature. So the first concept which you should remember in basicity is basicity increases with increasing in negative charge. So wherever you see negative charge increase, immediately you will put that is more basic in nature. Now let us come back and do the next thing. So again in trick 9, one more concept about basicity. Yes, next thing, that is more unstable, means if I have to speak in terms of stability. Right, students? Right? So okay, let me a little bit change the term and tell you. Lower charge density. One more thing you have to remember in terms of basicity questions. Lower the charge density, then what will happen with stability? I just little bit I have changed. More will be the stability. I'll explain you with an example. Then what will happen? If the charge density is lower, the basicity also will be lower. Lower the basicity. Okay? Yes, students? Remember, lower the charge density, more will be the stability. If it is lower charge density, more will be the, lower will be the basicity. Right? That means if I have to take an example, let me take an example and I'll tell you. Resonance stabilized. Just say, students, resonance stabilized amines. Whether they are more basic or less basic, they are less basic. Let us see what is the concept about this. So note this. First of all, lower charge density means it is more stabilized. If it is more stabilized, it is the least basic in nature. So I have taken an example. Let us draw the structure and see. So I said resonance stabilized amines are less basic in nature. Right? So let's see. Let us draw, taking this as an example for the second category. So what did I say? Resonance stabilized amines. If I take one example, non-benzene ring, where amines I said, so NH, lone pair, then this is resonance stabilized, one more, NH2, one more, which doesn't show any resonance. I said resonance stabilized amines are less basic in nature. So among all these, which is resonance stabilized? This one. Here it is less basic. Then again the next amine is this, which is again, here in this case there is no resonance shown because of the absence of pi bonds. That's why it is more basic. Let us write that. First of all, I said resonance stabilized amines are less basic. So here the pKh value, how much is it? 0.78. Here pKh value is how much? 4.6. Here the pKh value is 11.2. So which is resonance stabilized? This one. Hence this is least basic. So in the exam paper, this is more basic. So in the exam paper, the first thing you'll see, if it is resonance stabilized, it is least basic in nature. So what was the earlier concept which I taught you? If the negative charge is more, then it is highly basic. Second concept I said, if it is resonance stabilized, it is least basic. If there is no resonance, it is more basic. Yes, students. Now, let us come and see the next concept in basicity. Yes, students. Yes. So, right. So, important thing. Here, it is C part, isn't it? Right. Always remember resonance and inductive effect. What is the effect on resonance? They reduce basicity. If a particular compound shows a resonance as well as inductive effect, the basicity is reduced. Yes. Next important thing. Basicity, I forgot to put I here. It increases with which one? Decreasing S character. Remember this is one more concept. If the S character decreases, that means in which one? In which one, students? It is nothing but sp3. So basicity, it increases with decrease in S character. Now, I said sp3 25% is S character, in sp2 33%, in sp it is 50%. So wherever basicity means if the S character is less, basicity will be more in that. Right, students? So with this, one important key thing which you have to remember. Yes, students, I am writing the key word. Remember, students. Yes, in trick 9, what is that? I am writing in inverted commas. Note it. Yes, students. The stronger the acid, what will be the thing? The weaker the conjugate base. This is one important concept, conjugate base. You should remember. Next one. The weaker the acid, the stronger the conjugate base. Remember this, students, very important thing for the exam. Stronger the acid, Weaker is a conjugate base, weaker the acid, stronger is a conjugate base. Let me come back and meet you with the next trick. So we'll summarize the acidic and the basic character by learning the order in the trick 9. So this is the order, students. Remember, always this is more acidic than, means alkynes are more acidic than alkenes, which are more acidic than alkanes. This is more acidic than acids, which are more acidic than alcohols, which are more acidic than water, more acidic than H, more acidic than NH3, which is more acidic than an hydrocarbon. If I have to see the basic nature, remember, R more acidic than, more basic than NH2, more, I think I have to, yes. So CH minus, see the acidic hydrogen, then RO minus, more acidic than HO minus, more acidic than phenoxide, more acidic than RCO, so more basic than RCO minus. So this is the concept of trick 9. Let me come back and meet you with the trick 10.